This video will look at operations with rational expressions. Now you already know how to multiply and divide rational numbers, and the process for rational expressions is the exact same. The first thing you look to do when multiplying rational numbers is to cross simplify. What do I mean by that? Let's say we have 1/4 times 8/9. Right? We can cross simplify because they both have a 4 in it. We can divide both by 4. 4 goes into itself once, and 4 goes into 8 2 times. Now we multiply across and get 1 times 2 is 2, and 1 times 9 is 9. We're going to use that same technique. It's just that it might not be that obvious. Our old friend factoring will come back into play. So looking at number 1, we're going to need to factor this expression, and this expression to help us simplify everything. So let's start by factoring what we can. This expression would be equal to our x squared minus 2x plus 1. That will factor into x minus 1 times x minus 1. Our denominator will just stay x minus 3. Our x squared minus 9, that'll factor into x plus 3 and x minus 3. So see how that factoring really comes into play here? It's really useful to be able to factor well. And finally, on the denominator here, we could factor this into x minus 4 and x minus 1. Now, when we're looking to cancel factors, we can look either diagonally across, just like we did here, or we can also look straight up and down to cancel out factors. So let's see, we can cancel an x minus 1 and an x minus 1, and an x minus 3 and an x minus 3. Let's see what we have left. In the numerator, we have an x minus 1 times an x plus 3, and in the denominator, we have just that x minus 4. And you can leave your answer just in that factored form. You don't need to multiply it out. And now division with rational expressions is just like division with rational fractions. Remember, when you have a divided by sign, you can change that to multiplication and then flip your second term, or you may have learned keep, switch, and flip, meaning you're going to keep the original term right there. You're going to switch the sign from division to multiplication, and then you are going to flip the second part right there. And we can do exactly those same steps when we have rational expressions. So here we go. Let's try this problem. So the first thing we want to do is rewrite this using that keep, switch, flip. So this is going to be equal to x minus 3 divided by x squared minus 4. Then we are going to change to multiplication. We're going to switch the sign, and then we are going to flip the second fraction. So this is going to become x squared minus 7x plus 12 in the numerator, and the x squared minus 9 will go in the denominator. And now we have and I might change that to a dot, just a multiplication problem where we are going to factor and cancel out like terms. So let's factor this out, and voila, there are all our factors. Right, the x squared minus 4 became x plus 2, x minus 2. Our x squared minus 7x plus 12 is x minus 3, x minus 4. And our difference of two squares becomes x plus 3 and x minus 3. Now again, we're looking to cancel out like factors, either crossways or straight up and down. So what do we have in common that's in both the numerator and the denominator? Well, I have an x minus 3 here, and then there's both an x minus 3 in two places in the numerator. Now you can only cancel one of them, right? So I'm going to cross out one of my x minus 3's in the denominator, and then it doesn't matter which one. I'm going to choose this one, let's say, and cancel out only one of those x minus 3's. And sadly, there's nothing else that can be simplified, so our final answer will be x minus 3 times x minus 4, and in the denominator are x minus 2, x plus 2, and x plus 3. And there's your answer. And finally, let's look at adding and subtracting. And yet again, you're going to do that the same way you did adding and subtracting rational numbers, which means, yes, you need a common denominator. If we had 1/2 plus 2/3, if you're going to add those numbers, you need a common denominator, and in this case, it's 6, right? We can change the 1/2 into 3/6, because 2 times 3 is 6, and 1 times 3 is 6, and then we can change our 2/3 into 3 times 2 is 6, so 2 times 2 is 4. And you're going to end up with 7/6. And remember, to add them, we got that common denominator by multiplying by a form of 1, right? 3/3 and 2/2 to end up with our groupings with 6 in the denominator. So when we look at this first problem here, I have two rational expressions. One has a denominator of x minus 1, the other, not the same, a denominator of x plus 2. So together, our common denominator will be x minus 1 times x plus 2. Now you have to ask yourself, what do I need to multiply each expression by to get that as my common denominator? Well, the first one, right, we have the x minus 1 already here. So we're going to need to multiply this by an x plus 2, but again, it should be a form of 1. So I'm going to multiply the left by x plus 2 over x plus 2, and that's for this expression right here. And then the right side, I'm going to multiply that. I've got the x plus 2, but to get it to be x minus 1 times x plus 2, I have to multiply this by x minus 1 over x minus 1. So let's look at what our fractions now look like. Our left fraction is here, and our right rational expression is here. Notice now we have the same common denominator, the x minus 1 times x plus 2. We just now need to simplify that numerator. And I would suggest multiplying that out first. So go ahead and change the left side to 3x plus 6. Remember to distribute. And then plus x squared minus x. Now if we further simplify the numerator, and then you want to check to see if can we now factor this to further simplify. And in this example, you can't. So this right here will be our final answer. So let's look at one more. We have 1 divided by x squared minus 1 minus 2 over x plus 1 squared, all squared. So our denominators are not the same, so we're going to have to look for a common denominator by looking for the least common denominator. You might be thinking to jump ahead and just say, let's take this times this and make it our denominator, but to make it a little bit easier, notice that left side is really made up of x plus 1 and x minus 1. So the entire expression we could rewrite, if we completely factor it out, is this. Now we need to find our least common denominator, or our LCD. And that you find by first finding what they have in common. So they both have an x plus 1 and an x plus 1. And now you just tack on what else is left over. We have an x minus 1 and we have an x plus 1. So this will be our common denominator for both terms. So now let's look to see what we have to multiply each term by to have this common denominator. So the first term on the left, it has the x plus 1 and the x plus 1 here. It also has an x minus 1 and an x minus 1. The only thing it's missing is an x plus 1 times an x plus 1. We can do the same thing for the second term, right? It's got an x plus 1, just like our x plus 1 here. It's got the other x plus 1 in purple right here. The only thing it's missing is the x minus 1. So let's multiply it by a form of 1. Now if we're going to rewrite this entire expression, now that our denominators are the same, we can combine our numerators. So this will become our x plus 1 times x. Our x plus 1 times 1 is just x plus 1. And our right side will be a minus 2 times x minus 1. We can continue to simplify and get x plus 1, and be careful of the negative sign, that's going to be a minus 2x, and then remember to distribute that, and that'll be a plus 2. And finally, we can combine everything and get minus x plus 3 for our numerator. So our final answer will look like negative x plus 3 in the numerator over x plus 1, x minus 1, x plus 1, and that's perfectly fine, or combine those x plus 1s and write them as x plus 1 squared. Either one of these is fine. With these problems, the goal is to find the least common denominator, or LCD, and then ask yourself, what do I need to multiply each term by so that the denominator has that same LCD? And don't worry, we'll get lots of practice with these problems in class. See you soon.